Uh, but yeah, I mean that's I'm just going to talk about Locomotion, give you kind of an overview, and also about what to do about cybersickness, which is motion sickness for VR. But I guess I'm ready to go. So
Cool. Thanks.
I'll just see how I can make this work. Okay. So I want to first make an introduction, but I guess most of it has been said. Um, I actually started as industrial designer at Twente as well, but then I realized I really like digital devices and designing for them. So that's how I ended up in HEID. And this is also where I found out about virtual reality, and I realized it's also pretty cool. And doing this course really made me think about all the interesting experiences that you can find out about through VR. And that's also why for my master thesis I kind of looked for companies that were doing something with virtual reality. And i I found this company in Vienna that makes these so-called omnidirectional treadmills which you can walk on. And then I realized there's one problem for me, at least, is that I get sick if I use VR. I mean, not immediately, but I get a little bit sick and it's not so nice. So I thought maybe I should do a thesis on that. So I did a thesis, and then I published an article as well afterwards with my supervisor. And that's how I eventually also ended up at the company here in Vienna, which is called Cyberif. And now I kind of work on Locomotion. So I make software, but also I kind of develop the user experience side of it. So first, yeah, I want to give you an overview of different locomotion types. So how to move in VR. And there's kind of two general ways of moving. So there's the real movement, which is basically the virtual movement follows exactly your real movement, so your physical movement. So if I move my head forwards, the view in VR also moves forwards. And this is the most comfortable, I would say, and it feels very realistic. But it has some limitations, and that's why there's artificial movement. And this is basically when the movement is only virtual and not in your actual physical world. So first, let's start with real movement. So the real movement, most of the time you combine it with artificial movement, but there are experiences where you don't have to use artificial movement. So this is, for example, when you have a room scale experience. So when everything that happens in VR is within the bounds of your room or the play area that you set up. So an example, for example, is Beat Saber. This is a game where you try to smash through blocks that are coming at you on the rhythm of the music. It's a bit like Fruit Ninja and Guitar Hero combined. And because everything is coming at you, you don't really need to move around. I mean, you move a lot, like it's really exhausting, but it's not like you need to move 20 meters to the side. So it works very well on room scale. But sometimes you actually want people to explore a big space, but there's still a solution to do that within your room, and it's called impossible spaces. So I'll just start this video so you can see. In this case, what they create is kind of like an Azure type of um, experience where locations are kind of put very strategically, so you always kind of walk in circles. But because you're so immersed in VR, you don't really realize. So for you, it will feel like a space that's endless. But technically, they're kind of smartly placed teleports. So you're always kind of turning around and moving back to the center of your room, which works pretty well, but of course doesn't work for all games. Like you need to have really small, how to say, narrow rooms and this kind of stuff to be able to do this. So then there's artificial movement, and there's a few different types that I want to discuss with you. So there's the most popular one or the most common one, which is avatar movement. There's scripted movement, steering movement, environmental movement, teleportation, and role pooling. So first, let me start with avatar movement. So the idea of avatar movement is that you as a user are able to control a continuous movement from point A to point B. And most of the time, most games, I would say, they use a thumbstick. So if you have like your controller, your VR controller, you can just use this kind of joystick thing to move around, and it's pretty easy to use and it's quick to control. And also for you as a developer, I think it's kind of easy to implement because it's so commonly used. And what's also nice about it is that for people that are familiar with the normal video games, they already know this way because it's used, of course, a lot for like console gaming and this kind of stuff. But of course, if you have somebody that's really not used to using VR or using video games, then it might be less intuitive. And I think the main downside is just that it's not that immersive than if you have a more embodied way of moving. So what you can do is you can kind of simulate a real movement. So you can use the motion controllers that come with most headsets. So most headsets, if not all, I think they have some kind of controller that you can hold in your hand. And because it has a location and it has a speed, you can basically track this thing. It's like a motion tracker. And this you can use to move around and to kind of simulate a movement. So it's like walking. So you can swing your arms as if you're walking, or you can flap your virtual wings, or you can start swimming. And this will feel a little bit more immersive than just using your thumbs to move around. And what's nice about it is that you don't really need third-party hardware because you already have the controllers in most headsets. But the only thing is that it's also not like the highest quality simulation, I would say. Like it's kind of a quick and easy or dirty solution to actual walking. But if you want to really kind of get closer to the actual walking experience, you will need extra hardware. So there's different ways of having walking simulators. So for example, you can put motion sensors on the legs and you can kind of walk on the spot. So you're not really walking, but you're kind of the movements of your leg are defining your movement. And another thing is another company, Cybershoes, which is actually also from Vienna, where I'm now here currently working. They have these shoes where you're sitting on some kind of chair, and then there's like these rollers, like you see here. There's like a roller on the cyber shoe, and you kind of glide it on the floor, and that's how you move around. And then the last one I think is the most closest to real walking is the omnidirectional treadmill. And treadmill is not really, I would say, the most accurate word to describe it because there's not an actual treadmill moving under you. You're rather like sliding. So I think the word that I see sometimes people use to describe it, I think is more fitting, is the slide mill. So let me just start the video so you can see it. It's basically you are sliding, and this is how you're walking around in space, and you can walk infinitely in any direction. And what's nice about it is that it makes the experience more immersive. So it makes you feel more like you're really moving from place A to B. But it's not exactly like walking. So people might expect like, okay, it feels like walking, but I think it feels a little bit different than what you expect it to be. So I would say if you want to use something like this, use it if you really need to, or if it fits the experience. So I think it's very nice if it's in a game that's like a shooter or a horror game where it feels like it's important to the experience that you're physically walking. Like it's actually, more exhilarating if you're running away from a monster, or then rather if you just use a joystick. But if you're having an experience where you just casually walk through a museum, I don't think it adds much. And it's just the major downside is just that it's kind of tiring as well. So it's not a very easygoing experience. And then I think it's like then it's not really worth it. So it's better than to focus on something else rather than putting people in this like extra hardware and having them teach how to walk on it. It's too much for an experience like this. And yeah, so you need extra expensive hardware, but at least at Twente, I know there is a virtualizer. So the virtualizer is the device from my company, which is the one that you just saw in the video. And this virtualizer, I think, is in the BMS lab. So if you want, you can use it, but I would encourage you to first try it, so you have a kind of an idea of it, if it even makes sense to add it to your experience. So the next one is scripted movement, and in this case, you have the virtual camera follow a kind of path, so you don't, the user doesn't directly control it. So, for example, you can have a cinematic camera move, or you have like roller coasters, they follow a path, you're sitting in the roller coaster and you don't do anything basically, or sitting in another vehicle. But the only thing is, with scripted movements, especially with roller coasters, they're quite intense and they can make you motion sick as well. If you don't control it yourself, it kind of makes you more easily sick. But there's one experience or app that I want to show you, which is Eye of the Temple. And I think they really kind of make a very good combination of real movement and scripted movement. So in this sense, they use the scripted movement to keep players always within the 2 by 2 meters. So it always forces players to kind of walk back to the center. And even though you only move within this 2 by 2 meters, it will still feel as if you have kind of an endless space to explore, which I think is very nice. Even it's like a relatively simple solution to this. Now for the next one, we have steering movement. And in this case, you use the user steering a vehicle. And when you're steering a vehicle, this also includes inertia and momentum. So what happens, of course, in real life, if you are steering a car, the car doesn't instantly stop when you want it to stop. There is some time it takes until it comes to a full stop. And this is also what users expect in virtual reality. So you have to keep in mind that you kind of need to add a little bit of virtual inertia. And what's nice about it is that you can do it fully virtual, but you can also make it partly physical. So add like a more tangible experience by adding, for example, a physical bike or a steering wheel with gas pedals and this kind of stuff to kind of give you a more immersive feeling for it. Now there's also environmental movement, and this is not really something you will focus on a lot probably because it's not the main mode of transport, let's say. But it's basically when your view is moved by something around in your environment, or there's gravity kind of pushing you down. So an example would be you're being pushed by another character, or there is an explosion, or you're sinking in water, or you're falling down. But also with this kind of movement, just like with scripted movement, it can be also motion sickness inducing, and also can be disoriented. Like if you're suddenly pushed away, it's maybe hard to, you kind of lost track of where you were exactly or where you are now. And this especially when it's unexpected. So I think if you do use it, it's maybe good to make it kind of something that you can expect happening. Now, if you do want to have people moving around, but they feel very easily motion sickness, teleportation is often used as kind of like an alternative to using like a joystick to move around. And it's often provided as an option, so it's not the main one. But there are some games, for example, that put it there more as a gameplay mechanic, so that you can hop from spot A to spot B and quickly move on. Or you can use it as like a major transition in your story, so that you move from, I don't know, scene A to scene B. But the thing is that especially if you use it as a way to move through your scenes or through your world, it's quite disorienting. And I think it's the least immersive way of locomotion. So I think it's good to provide it as a backup, but I wouldn't make it necessarily the main way to move around. But what you can do to make it at least a little bit less disorienting is like how they did it in this GIF that I added from Half-Life. Is that you kind of put a trajectory and then an animation of steps walking. So you kind of have more the feeling of where you are moving and where you will end up in the end. Now for the last one, there is world pulling, and this is when you're moving by pushing or grabbing the world around you. So you grab a point, for example, in this first game, Lone Echo, it's like a zero gravity world, so you can only move by holding on to something and kind of pushing yourself around. And in the other one, it's more about climbing. So if you have a ladder, you can use that to kind of walk up the ladder. So these are kind of like an overview of different ways to move around. But there is a lot more. There is really too much to kind of get into. I probably forgot like 10 different ones that maybe you should have known. But I have this, I found this website that is, I think, quite useful. It provides like a very comprehensive overview of all kinds of different ways to move around in VR. The only thing is that it's from 2021 and it hasn't been updated since then. But I think it's still pretty useful. I mean, 21 is not that long ago, but there might be things that people came up with that are not in there. And before I move on, I also want to say I think Locomotion is really important for VR because it's such an immersive experience. It's kind of important to also have an immersive way of moving around that fits the experience you want people to have. And I think it's much more engaging if you have something that's more embodied rather than just using your thumbs to move around. So I would really kind of encourage you to try to be creative and try to really think about what can we do to make our experience more immersive in the way that we move around. So I think that's quite important. And as a last note as well, I think, as I said before, it can be tiring if you have a more physical movement type. So for example, the virtualizer here in the back of me, that one can be tiring. So make sure to adjust your experience to this as well. Or if you have a long experience, have the possibility for people to sit down during the movements, so that it's maybe not as tiring, because it's definitely, you will not be able to do this for like an hour like you could do with a normal video game. So now that I gave you kind of an overview about Locomotion, I think it's time to talk about the more dark side of VR, which is cybersickness. And the thing is, with cybersickness, it's kind of like it's a kind of motion sickness, but specifically for VR, but also for other computer-based things or experiences. And it's very similar as in the sense that it has the same symptoms. So you will feel dizzy or nauseous or maybe get a headache. But the way it starts, it's maybe a little bit different, or the source of let's say the sickness is different. And I think in general, cyber sickness, for most people, it's fine. If they use VR, at least in my experience, people either don't get sick or they get maybe slightly sick. But there are some people that get very sick. Like when I was doing my research, I had some people that took them only a few minutes until they felt like too bad to carry on, and they had to like leave, and they felt still bad for like several hours. And for those people, it really sucks. So imagine that when you're making your experience, there will probably be some people that never tried VR. And if you want to have an exclusive experience and then they get sick immediately, probably they'll be like, well, I'm never going to try this shit again because it's just too sickening. So it's, I think, quite important to try to adjust your experience to this, or to make sure that you can accommodate these kind of people. So I want to first kind of explain also where does this come from? What's the theory around cyber sickness? So the main one is the sensory conflict theory. So the idea is that you get sick because there is a conflict between your senses. So in VR, you are seeing movement, so you see yourself moving. There's the visual stimuli, but then your vestibular system, which is like this organ in your ear, which is supposed to kind of feel accelerations, doesn't feel anything. So there is like a conflict between these two things, and then your body is like, okay, now I feel sick. And this kind of experiencing movement, it's called vaction. So this experiencing movement from visual stimuli. And the thing is with vaction is that it's the most you're the most sensitive to vaction or to motion when it's in your peripheral vision. So in the center of your eyes or of your view, everything is very detailed and it has color, but everything around is kind of grayish and blurrish, but it's very sensitive to seeing motion. And this is kind of how you're able to spot all the dangers that come from the side. So it's kind of important, I think, to realize that it's mainly or not mainly, but that's a very important part of your view that can create the sickness part. So what can you do? The thing is, or the problem is that you cannot eliminate cybersickness. Unfortunately, there will always be people that will feel sick because there will always be a conflict between what you feel and what you see, and this you cannot do. But there are things that at least you can make adjustments to, and to avoid for some people to get sick, or to at least minimize the symptoms. So the first thing I would say is to focus on the locomotion side of it. So this is a little bit of a checklist, I guess, and it says a lot of things that you should not do, but I wouldn't say it's necessary that you cannot do it, but I would say be mindful about it. Know that if you add, for example, artificial accelerations, people might get sick from it. So what you can do is, if you need it, try to at least make them less intense. So don't use very high accelerations, or don't use it very often or very quickly after each other. And in the same way, for example, moving sideways is more sickening than moving forwards. I don't really know why it is like this. I just know know that if you move sideways, somehow it feels less comfortable. So I would say try to focus really on moving either forwards or backwards when you make your VR experience. And also, perhaps maybe one reason why sideways can be more sickening is that it may be more unpredictable. Because this is also something that can make people sick, is that if they don't realize that they are going to move, the next moment, their brain somehow cannot comprehend, and this also can make you sick. So I would say try to avoid making it unpredictable, and you can make it more predictable by, for example, providing kind of a visualization that something is moving in a certain direction and a certain speed. So if you have, for example, an elevator somewhere, then it's good to kind of show which direction the elevator will go, or give kind of a preview of where it will go. And another thing I think that kind of makes people more sick on average, is if you are rotated artificially. So this is something that's, I think, relatively popular in games where you're fighting with enemies from multiple sides. And if you're sitting in a chair, it's kind of hard to quickly turn around. So what you can do often is that they add like a way to rotate your view. But this is not that nice and comfortable. But what you can do is you can add the so-called snap turn. And this is kind of like a teleport, but for just rotating. So you're basically instantly rotated like several degrees. So you don't have this acceleration, and it will feel more comfortable. Not that immersive, but at least it doesn't make you as sick. And then what's, I think, kind of quite important as well, is that you provide options to the user. So I mentioned before also the teleport as an option. But what I also found in my thesis research, that speed is quite important. So if you are moving very fast, you will feel more sick, at least if you're susceptible to it. But there is a little bit of a paradox in it, in the sense that if you get sick, you will get more sick from going faster. But if you put it very slow, people will also dislike it because it's very boring. People want to kind of get to somewhere relatively quickly. So I think it's good to have an option for people to have different speed options, so that they can adjust it to how they like it. and kind of optimize it for what they have. Because if you provide very slow speeds for everybody, there will be a lot of people very bored. Or if you provide very fast speeds, there will be a lot of people maybe leaving your experience and searching for a bucket to throw it all out. So it's always good to provide options, not too many, but at least a few. And the last thing you can do with locomotion is that you can reduce the field of view. So this is basically when you start to move or when you're moving, you can add kind of like a vignette or a tunnel to your view, and this kind of reduces the stimuli, so it obscures a part of your view. And like I said before, the periphery is what is most sensitive to motion. So if you obscure that, it has the most effect, and because your focus is on the center, it also doesn't affect as much the experience. You will still see what you find the most important part to look at. So, and this is a good thing to provide as an option. So I wouldn't turn it on automatically because it's still nicer to have the full view. But for people that are more sensitive, it's nice to have. It's better than feeling sick, at least. Now, there's also a lot that you can do about the environment that you're building, so your virtual environment. And I think the first thing that I really want to emphasize is that make sure that the world that you're moving in is flat. It's really uncomfortable to move vertically in VR. It's just really not nice, I would say. And I know it's in normal games this happens all the time, no problem. But in VR it's not nice. I think the worst is actually if you're falling from something. It's really a weird experience to fall and then suddenly you hit something and all the time you're just standing and technically not moving. And it's very off-putting, I would say. So I think it's best to avoid this, like at least the falling part. Of course, there might be times where you want to have people moving up or down, and then at least then it's best to either use a ramp rather than a ladder, so that it's more smooth to go up or down. Or what I like maybe more is to have a closed-off elevator, so that you don't see that you're moving, but you are at least technically moving through the space. Or you can use a teleport, so you can put a teleport at the beginning and at the end, so that you can kind of go past this distance without having to move through it. And when I was doing my research, I also made this maze for people to walk in, and only afterwards I realized how much I was torturing people with this maze, because the thing is with the maze is that everything is kind of narrow and you turn a lot. And I realized only after that turning a lot and being close to the wall makes you specifically more sick, because if you're close to a wall, there is a lot more vacuum because things are moving faster visually. So if you have some big object all the way in the back, this will technically, of course, physically you're still moving the same speed, but visually it will be less intense. So I would say try to avoid moving in narrow spaces, or at least, it's nicer to have a big open space or open world in that sense. And if you do have to walk close to a wall or close to big objects, it can help to reduce the texture complexity. So if you have a more simple texture, it will technically reduce also the amount of action, because it's basically less visual movement happening. So this can help. I think it's not really like the big solution, but it can still be a small percentage for your experience. And then something that I have not mentioned yet, but is another kind of theory about why people get sick, is the theory that when you're in VR, you find it hard to find a reference frame that's stationary. So basically, if you're in VR, everything is moving and you don't know what exactly is moving, and this will make you sick. So it's a bit like when you're sitting in a train and there's a train next to you and one of the two trains are moving, but you don't know which one, and it gives you this very weird, wonky feeling in your tummy, perhaps. But as soon as you start looking at the ground, like outside, you get your reference frame. You have something stationary, and through that you can realize what is moving, what is not, and the whole weird illusion is over. And this same thing you can do in VR. So you can add a so-called rest frame, so something stationary around you that always stays in the same distance to you. So this can be sitting in a car or a cage or having a hat on. I even found the research where they use the virtual nose. And apparently this works. I have not tried it myself, but apparently you can just give people a virtual nose and then they'll feel a little bit less sick. But what you can do is, or what's nice about it is that you can really um, adjust it to your experience. So you can make it very specific to what you're doing. For example, in this game called Vox Machinae, like this, where this picture is from, you see they have something that fits. Like it doesn't feel weird to sit in this, and so it's cool. It helps for the experience, but then also it's actually helps feeling you less sick. So that's nice. And what you can also do is you can do things more in the background, so like clouds, mountains, a horizon, and this should also help. But of course, this is more if you're having an outside world experience. So in a room, it might be a bit weird if you suddenly start seeing mountains and clouds and this kind of stuff. And the last thing that I want to tell you about is about the frame rate. So normally an experience would kind of run around 90 frames per second. And I would say it will make you sick for sure if it goes very low. So as a recommendation, I would say try to test out your experience on the hardware that you will use it on eventually, so that you can be sure that it's not too graphically heavy. And if it is, then it's better to try to optimize it, because I think this kind of stuff is the most sure way on how you can get people sick if you start lagging. So if you start moving around and the view is not moving in the same way, it's not nice. It's not nice. So I would try to avoid that. So now I was talking mainly about things that you can do in the software, but there's also some things you can do kind of around the experience. So as a kind of assistant or operator of the experience, there's a few things that I would do when you're inviting other people to use your experience. So the first thing is, if you have somebody coming in, ask them for their previous VR experience. And this allows you to kind of see if somebody is new to VR or if they had a bad experience before, and if you need to adjust for that. So if they are new, it's probably good to keep track of them while they're in VR. So ask how they're doing. And it's also good to realize that people might not realize themselves that they're getting sick. At least when I was doing my research, there were people that were feeling fine for the experience, or at least didn't say they were feeling very bad. And then they came out and they said it was getting worse. Like then they were getting really sick. So just be aware that people might want to go on, but then afterwards feel very bad. So I would say if things go bad, it's probably good to adjust the length of the experience, or have the possibility to adjust the length, so make it shorter if somebody cannot handle it that well, or to have the possibility of breaks and being able to go outside if it gets really bad. And going outside really helps because you have the fresh air and you have kind of you're more grounded again in reality. Like you can feel things again and everything works normal again. And this is, I think, much nicer. But for most people, it's fine. This is just as a, let's say, backup, like if it really gets bad. Um, and then in the room itself, I think it's kind of useful to also have this fresh air kind of coming at you with a ventilator. So this kind of reduces a little bit certain symptoms that you can get from motion sickness. And also it's nice if you get warm, because in VR, especially if you use something like the virtualizer or anything else that requires kind of a lot of movement, it gets pretty warm. Like putting on this headset that blocks off like a lot of your face is quite, yeah, it makes you hot. So having a fan is kind of nice. And in that same sense, I would say make sure that the room is not too warm and that there's enough oxygen. So basically, you need to kind of control the climate a little bit of your room. And then the last thing, when you've done all of this, the last step before you put somebody in VR is to adjust the IPD. And the IPD is the interpupillary distance of the lenses. So this is basically the distance between your two pupils. And this is different for everybody. and most VR glasses, or headsets, they can adjust this. So often you have like a little knob on the side that you can adjust it. And I would say try to adjust this every time before somebody starts. It's not like somebody will feel immediately bad when it's not correctly set, but after a while you might get some like eye strain. The only bad thing about IPD is that I don't know if current headsets are all good, but at least older headsets, they were often not well adjusted for women. So the range was often too high for part of the people that were mainly like female users. I don't know if it's fixed nowadays. I'm not sure, but at least it's good to keep in mind that even if you're adjusting it, you might not able to get to the perfect distance for all of your users. But that's kind of in general it. So as a final note, I want to just emphasize, test everything, test it with many people, test it with different people, because VR is such a experience that's different for everybody. Like when I was doing my thesis and doing my research, I could not predict how sick somebody would get from VR. It almost felt random, at least if they hadn't tried VR before. And so everybody kind of has their own style, their own preferences. So I think it's good if you try it out with different people and try out what works and what doesn't work. And I think you can come up with great ideas, concepts, but it will work very differently in VR than it might work in your head. So I think in that sense, it's good to test it and you realize what are kind of important things that we should provide in our experience. But on the other hand, I would say try to not make too many options. So if you want to accommodate different types of users, it's better to not provide a million options because people then are just drowned in options and nobody does anything. It's too much effort. So what's kind of a good way to do it is just to provide three settings. So you have comfortable mode, normal mode, and intense mode. So basically comfortable is for your beginners. You might have something like this field of view reduction, slower speeds, and all this kind of things. And then when people tell you that they feel fine, you can increase it and kind of go along this way. So that's kind of everything. So thanks for listening. I don't know if it's possible to do questions easily through this presentation mode. But if you have any questions, you can ask it now, and otherwise you can also send me like an email, or I think a contact form on my website. I have LinkedIn, all this stuff.
Cool. Thanks, Jester. At least I have questions, which is a backup, but questions from the room, because those are more interesting for me. Yes, I will recap the question because you're not going to hear it from my crappy laptop screen.
Yeah, I guess so.
Yeah. So what kind of durations are you thinking about for a VR experience? How long should it last in your experience?
I think it really matters, or it depends on what is the experience, right? So for example, when I was doing my thesis, I was first making kind of like a pilot, and I was doing 10 minutes. So I had people walk 10 minutes in VR, and I tried it out on a few people, and I quickly realized it's tough. Like at least if you're kind of sensitive to it, it was really tough for people, and I quickly realized I was gonna lose a lot of participants if I would give them 10 minutes. So I shortened it to 8 minutes, and then I had like 4 blocks of 8 minutes. So I had like 8 minutes and a break of 10 minutes and 8 minutes break of 10 minutes and kind of this stuff. But I also adjusted a little bit the break based on how good or bad people were feeling. But this is, I think, kind of an extreme example because I was putting them in this very sickening maze and I was making them walk, which is super tiring after a while. So then it doesn't work so well. But if you have a calm experience where maybe you're just sitting, you can do it longer. But like I said, you need to try it out. Like you need to try it out with somebody, find somebody that you know that doesn't feel easily comfortable. Then if they like it and it's good for them, then you know for sure people will will be fine. But I cannot tell what's the general rule, I would say. So I'm sorry, I cannot give you the final answer.
Good question. So one question I had was, are there certain ways of locomotion which are maybe harder for less experienced users, like very old people who are not used to gaming or other things? Did you run into trouble yourself with like trying out locomotions in that way, that the usability was just too difficult?
So I think things like treadmills, like the omnidirectional treadmills or slide mills, I think they really require a little bit of training, because of this sliding mechanic, it's not immediately intuitive for everybody. So people will not feel immediately comfortable. So for example, when I was doing my research with this one, I was first kind of giving a little training session for people before I actually put them in the maze, so that they knew how to do it. So this kind of stuff, if you use a more, let's say, complex way of moving or extra hardware, just realize that people might need a bit of training beforehand. But if you use a controller, of course, it's a bit more simple. And I think in general, it also helps if you are like doing something that resembles a real movement, like flapping your arms is pretty intuitive in general, like people understand how that works. So this is also something to keep in mind, to think about how intuitive is my way of moving.
Yeah. So just was wondering why you think the walking in that surface is hard? Is it because are you pushing the surface backwards when walking, or is it moving like when you take a step, it's automatically moving like a treadmill does?
Did you hear the question, Jesse?
Yeah, I think I heard it. So basically, why is it difficult, right?
Yeah.
So what makes it difficult is that you have to slide, and this is something that is not immediately intuitive. Like if you get used to it, it's an easy way of walking, I think. Like for me, I don't feel uncomfortable walking on it. For me, it's a fine way of walking, and it's like a really good way to simulate walking, because I know what to expect. But if it's the first time, it's not immediately intuitive that you first have to start sliding and only then you can step. Because in real life, if you are gonna start moving, you first start moving forwards. But of course, here you cannot move forwards because you're stuck in this thing, this ring. So the first thing you have to do is to slide, and this is kind of like a leap of faith that you have to have, because you have to slide and believe that you're not gonna fall all the way down. And this is a little bit, but I wouldn't say it's like deal breaking. It's just good to know that this is this. Some people have more difficulties with others. Like most people will have this within a few minutes, will understand how to do this, and they will walk just fine. But there's always a few people that are just, I don't know, motorically speaking, less stable. That's just kind of how it is.
Also, when you have combinations of motions, like for example, let's say you want to walk and then jump, like let's say in a game, right? Does that like conflict? Like when you're saying it's easier to walk, for example, when you get used to this in the device that you are building, but let's say when you want to jump, you need to use the controller instead. So does that conflict with each other? Like the way in which you interact with the world is different because walking is just natural, and then controller based jumping is somewhat different from actual walking.
So yeah, that's the thing. If you use like a mode of movement like this, you will probably not, or you should not include jumping as a way of moving. Like you can do something like stepping over something, that's okay. You can add this, but for example, physically jumping doesn't work, and adding jumping through a button will just confuse people. At least I've never tried it, I don't know, but this is my intuition, that if you start adding a different way of moving, it will confuse people. And also, if you want to jump, have people jump in an artificial way, so by pressing a button and then you move up, like this is what I said before. This is creating like vertical movement that is artificial, and this will make people sick as well. So I think it's best to not add any jumps at all, in my opinion, at least.
More questions? Yeah.
I was thinking, is there a relationship?
Color schemes, you mean? Okay. So is there a relation between the kind of color schemes you use and sickness, and maybe also contrast, because it's about optical flow and peripheral view? So does that also influence then the kind of motion sickness it might generate?
I don't know, to be honest. I have not really found, like when I was doing my thesis, I tried to find a lot of different research on motion sickness, and I don't remember seeing anything about color in that sense. I can imagine that things that like visually stronger colors are more sickness inducing, but this is just my own hypothesis, right? It's like things that are more intense or that have more contrast will make you more motion sick. So if it's like a black background and things are like dark blue and that's moving, it might not make you as motion sick as you have if you have like a very white background and something, I don't know, red moving around. But I can only speculate about this. I honestly, I don't know.
Textures do work that way, right?
What do you say?
Textures. So what you just mentioned about a lot of detail in the texture, then you get more motion sick.
Yes. So but that's more about the complexity rather of than the color. So, but yeah, anything that basically creates more visual stuff happening, it will make you more sick because this is the source.
Yeah. I had one detailed question, but because for me it's a long time that I worked with you and the other student on motion sickness. So you have these two theories about what was it, sensory conflict theory and the reference frame. Are those complementary or conflicting? What's your view now that you know more about it?
I think it's, in a way, it's like complementing somewhat. Like it's more like a additional factor, let's say, at least how I see it. So part of it, it's similar in the sense that if you have a reference frame, it obscures some of the movement that's happening. So you have, of course, then there's less conflict, because if you have something that's stationary and you are stationary, there's less conflict. So I think in that sense it complements each other. But I think it also adds to the knowledge, or adds to the theory, that to think about this that there is reference frames around you, and that that is the difficulty, because sensory conflict doesn't really explain it this way. It just talks about purely about your biological senses. And I think as the rest frame, or this reference frame, it's more of like a cognitive way of looking at it, or purely cognitive, let's say.
And then one other question I had about so you said below 90 FPS hell starts.
I mean, not instantly.
Okay, it's a gradual thing. And of course, I know about optimization of polygons and textures, maybe some weird processes that might do things. Do you have other tips about how to optimize your Unity scenes or your Neo scenes?
And to be honest, I don't have a lot of experience in creating like 3D scenes and making them not as laggy. I mean, one thing that I do know is that you often have, of course, you add lights to your scene, and one easy thing that you can do to make an experience less or more optimized is by making the lights static. So basically, you can bake the light. So when you have a light, normally in real life, of course, if I put my hand in front of the light, there's a shadow and everything is kind of dynamically adjusting to the environment. And what you can do is in Unity, or in, I guess, probably any editor, you can kind of bake this light. So you can create the textures with the light adjust to it. So you place a light in your 3D scene and it kind of renders or scans how the light should work. And then it's just static. So it will always have this color, like all the textures around you. And this is a very optimized way of using that. But it, of course, it will look less nice, but it's better than having lag, I would say. So you can, of course, start first with having nice dynamic lights that give you shadow if things are moving and give you more like reflection and this kind of things. But if you realize that things are not working well, this is one of the first things you can do is try to optimize the lights and how they shine on things, or reduce the number of lights as well.
Thanks. Yeah. Final questions. No? Yeah, then Savio, do you have any questions, or via chat maybe? No questions. Okay, cool.